Good morning, children. You are able to see the presentation? Are you able to see it?
Yes, ma'am.
Okay. So let us quickly continue. We were in the process of finding out controllability and observability for combinational and sequential circuits. So we yesterday calculated the controllability, and in the fourth pass, I said that you should evaluate and see that the values are repeated. Pass 4 gives you the same values as pass 3. Since the controllabilities become constant, we stop at this paths. So these gives you the constant values of controllability, the combinational controllability and the sequential controllability. Right? It means we are able to control all the signals since we are specifying some number here for all the signals. None of the signal is with the value infinity. Agar controllability is equal to infinity, this means you are not able to control that particular signal. So here we are able to control all the signals, although the controllability is difficult for some of the signals, like putting a 1 on wire E is very difficult as compared to setting the value of A to 0 or 1. Right? Now today we talk about the observability. When we talked of controllability, we moved from primary input toward primary output and worked according to the levels 1, 2, 3, 4. Now that we are talking about calculation of observability, we will work backwards. We will start from primary output and will try to move towards primary inputs so that we know how your error is observable at primary output. So the first thing is the primary output Z. So we should initialize this value of Z. The initial values are to be 0 for combinational as well as sequential circuit because there is no difficulty in observing the fault on this wire. अगर यहाँ का value 0 था और अगर stuck at 1 हो गया, so the value will be directly observable. So there is no difficulty, hence we initialize the value as 0, 0 at the output. Now from output, we should move towards the calculation of observability for the inputs. So this Z is same as G, right? This Z is seen as output to this this AND gate. So using the controllability assigned for Z, we will calculate the controllability for E, which will be required to calculate the controllability of this D at the input of the flip-flop. Because the most important part is the flip-flop. If we are able to observe the fault at flip-flop, there will be no issue. Combinational तो easy ही होता है. So in order to define this flip-flop की observability, we want the observability for E, we want the observability for I. E की observability कहाँ से मिलेगी? From this wire. So we begin with the initial value of Z equal to 0 and try to find out what is the observability of any fault at E. Here. This is an AND gate. For a combinational circuit, we said that the combinational observability at any input is simply given as combinational observability of the output plus CC0 or CC1 for putting other input to non-controlling value. This is an AND gate. AND gate ka non-controlling value is 1. So I should consider CC1 of D added to observability of the output terminal. Output is Z, whose observability is 0. Hence, the observability of wire E will be given as kitna? D की observability, D की controllability CC1, which is 9. Here 9 plus output observability, which is 0 plus 1. So it means 10. So the combinational observability at wire E is 10. ठीक है? Sequential kitni hogi? The formula remains the same except for dropping the +1. So I calculate I use CC1 of wire D plus S0 for output, which is Z, that is 0. That gives me 1. So the observability of wire E is now 10 for combinational circuit and 1 for sequential. Now I have this value at the output of flip-flop. So I can calculate the controllability of its input, which is wire H. So now I look here. This is the third term that I should evaluate. This was the first term. This is the second term that I evaluated. Now comes the third term to be evaluated, which is H. The formula for controllability defined for sequential circuit is here. The observability. The observability of the input, the combinational observability of the input will be given as the sum of combinational observability of the output plus the clock edge. And if there is reset, the reset has to be 1. Then the change may happen. Okay. Sequential observability, almost the same formula. Sequential observability of the output plus the clock edge plus reset and an additional 1. So we use these formulas for CO and SO of input of D flip-flop, that is H. So how will be the observability of H? Observability of E, which is 10. Minute. Sequential observability of the output है नहीं हमारे पास, तो इसलिए the answer would be 2. So the observability of H is obtained. Now I have the observability of H. I can calculate the observability of the two inputs of this level 4 gate. I right now cannot calculate the observability here because I have no value or no idea about this I अभी, इसलिए हम अभी I को नहीं करेंगे touch. We talk about this H determined, which is 12 and 2. So using these values of observability at the output of the OR gate, I try to find the observability of the input. G तो मेरे पास already है, G is Z. I try to find out for F. This is an OR gate. The non-controlling value is 0. So I should use CC0 of G as CH, right, plus 1. So CC0 of gives me 3 when I am evaluating F as the fourth variable. Observability of F, SC0 G, which is 0. No, SC0 of G is 0 plus the observability of H, which is 2. So this gives me 2. So I have determined the observability at F also. Now that I have observability at the output of the NOR gate, I can the observability for this input. Inputs are D, E, and A. E I have already calculated. D we should calculate followed by A. So let us calculate D as the fifth variable. NOR gate है तो इसका non-controlling value is 0. So I should take CC0 of the other input, that is CC0 of E, CC0 of A plus CO of output, that is 17. Output is F. F का observability plus inputs का controllability for setting to non-controlling value which is 0. CC0 of plus CC0 of A observability here. So 17 or 9, 26 plus 1, 27 or 8, 28. और गेट का 0 ही होता है ना. A0 E0 okay. Calculate the sequential observability of wire D. Output का controllability 2 plus input का 0 that is 1. So 2 plus 1 is 3 and 3 plus 0 is 3. So this gives me 3. Fine. और मेरे पास A बचा. Calculate the observability of A as the sixth variable. Output का controllability plus CC0 of D plus CC0 of E. CC0 of D is 3, CC of E is 9, 9 and 3, 12, or plus observability 12 plus 17, 29 plus 1, 30. Sequential observability 2 plus 0. No, A तो हम निकाल ही रहे हैं. 2 plus D का 3 is 3. ठीक है. Now what left? Observability for B and C if I have the observability for D. So I have the for B now. Seventh variable. This is an AND gate, so the non-controlling value is 1. So CC1 of C, which is 6, plus observability of D, which is 28. So 28 plus 6, 34, and plus 1 gives me 35. Right? Sequential observability of D, which is 3, plus CC1 of C. So 1. So 3 plus 1, 4. Right? Calculate for C. D का observability 28 और B का CC1. So B का CC1 is 2. So 28 plus 2, 30 and plus 1, 31. Sequence D की हो गई 3 और C की 0. So 3. Right. That for I. I का कितना होगा? And this is using the observability of B. find out observability of A, which we have already found, but still we need to find if the value changes due to this B. B की वजह से कितना आएगा? 35 plus 1, 36 and 4. So if such a case is there due to fan out two different values, we will always take the minimum of the two. So 36 or 30 में से 30 is the minimum. So the combinational observability is 30 and sequential observability again is considered to be 3 because this is minimum of 3 and 4. So the value of A will be observability at A will be finalized as 30 and 3. This not considered. For the clock, the formula is given over here. The observability for the clock will be given as the observability of the output plus input control for Q and there the since we are run of output zero of input plus clock. So how much will this be? Observability of the output, which is E and I, ten plus C1 of out I का C C zero in 7 is the 3 has minimum value clock is 2. Just of output. C is zero H7. Okay, we calculated for both the cases differently. Then we'll see which one comes out to be lesser. For clock, the observability of Okay. So coming back to clock, इसका हो गया observability of the output is 10, input का 1, input का 0, input is h0 is 7 और output का cc1, output is e, इसका cc1, अच्छा वो लिखा था मैंने, ठीक है, प्लस क्लॉक विच इज 2, ये कितना आया 27, 34, 36. So एक वैल्यू आई 36, दूसरी वैल्यू आई 48. I take the minimum as 36. This is combinational controllability. Sequential controllability will again be the same formula, except that I'll consider the sequential observability and sequential controllability. So for this flip-flop, sequential observability is output की sequential observability, which is 3 for I, plus CC0 of input, SC0 of input. Input is D, so SC0 of D, which is 0. SC0 of SC1 of output, that is I. I का SC1, which is 2, plus clock. Clock is 0. So this gives me 5. Talking about this flip-flop, the controllability for the clock here would be the observability of E. Where is it? Here. So 1 plus CC0 of input, that is H. H का CC0. Output का CC1. So E का CC1, which is 2. Plus clock, that is 0. So this gives me 3. So I take the minimum. इसका 3 है, इसका 5 है. So I take 3 as the minimum, and hence the observability for clock, sequential observability, is given as 3. Fine. Now I am able to observe the output, observe the fault at any signal, since I have some specified value for each of the signal. Okay, so the circuit is completely controllable and observable. Any fault in the circuit will be observed and can be controlled. Okay, there will be one question in your examination for controllability and observability. You should practice it. Lastly, some uses of the calculated values of controllability and observability. We can use these values to check the testability index or to calculate the testability index. Testability index at any wire X with a fault stuck at 0 will be given as if the value is actually 1 and the fault is observable. So CC1 at X plus C0 of X. Similarly, if the wire or if the signal is stuck at 1, then the testability index will be given with the value CC0 at X, because actual value 0 honi chahiye since it is stuck at 1 as a fault. So CC0 of X plus the observability of X. We calculate this index T for every wire, right? And if we take sum of all those T's for stuck at 0 as well as stuck at 1 faults and take the log of it, we call it testability index. Higher the testability index, more will be the number of vectors required for coverage. Definitely जितना ज़्यादा हमारा controllability होगा, उतना हमें difficult होगा to control the signal. जितना ज़्यादा observability होगा, it will be difficult to observe that signal. So more testability index, the higher the testability index, more will be the number of vectors which is required to cover the fault at max. Okay. Therefore, you can use this concept, this value calculated for controllability and observability, to identify how many cycles of the ATPG algorithm will be required to run. जितना ज़्यादा testability index होगा, उतने ज़्यादा number of vectors हमें determine करने पड़ेंगे using the automatic test pattern generation. Right? Any problem in calculating observability and controllability? Here we finish with this topic. Any problem? सुनाई दे रहा है?
Yes, ma'am.
Okay. So here we finish with this controllability and observability. Tomorrow we shall begin with the last topic for your sessional examination, that is scan chain based design. अभी तक हमने sequential और combinational circuits देखे हैं. We worked for ATPG of combinational circuit, and then we modified the method for time frame expansion for sequential circuits. Now this sequential circuit testing method, that is time frame expansion method, is not very useful क्योंकि हमने देखा है अगर D sequence is sequence depth is 2, then I'll require 3 clock cycles. So instead of that, we use the scan chain based design. Scan chain based design simply means that now we will have the flip flops which can be controlled by using an external connection. So what we do is, instead of analyzing or controlling the input over the output, we add certain signals to it. Set, reset, or basically we add a control line to this flip flop and add a mux to it. Something like this. So that these D flip flop are no more just a flip flop, but they are converted into scan register. Shift register बना देते हैं हम इसको. So that all the D flip flops are connected in a chain. Path में मेरे circuit में जितने भी D flip flop होंगे, whether they are directly connected or not in the circuit, but they are directly connected using this scan chain design. So that if I provide any input here to the first flip flop, this will be shifted to the next flip flop, then shifted to the next, so that I can easily test the working of the flip flop by providing some input sequence. 0 0 1 1 0 0 जैसे ही मैंने इनपुट पे दिया, and if it is passed on clearly without any fault out of these 4 flip flop, इसका मतलब मेरे ये चारों flip flops सही काम करेंगे even in my circuit. So the fault on these flip flops is easily observed if I use them in the form of a scan chain or a shift register. So we'll continue with this in the next class, and that will be the last topic for your sessional examination. Your sessional examinations are near your Holi, I think just after your Holi vacations. So we'll have the fault modeling, fault simulation, ATPG for combinational circuit, ATPG for sequential circuit, controllability and observability, sequential plus combinational, and this scan based design. These are the topics that will be covered for your first sessional examination. And secondly, this Sunday, you will have again a quiz for ATPG of sequential and combinational circuits. That is your Boolean difference, D algorithm, time frame expansion method. Okay, is it okay? The same time, 12 in the noon. Is it okay, or anyone has any problem with that? Okay, since no response is received, I expect that this is a yes. So we'll have a quiz at 12 noon on this Sunday. What is the date on Sunday? 6th. So on 6th March at 12, you will have quiz on ATPG for combinational and sequential circuits. You will be required to do some calculations, and there will be questions for more than 1 mark which requires solving of the paper, question or the circuit. So you will be required to carry pencil and paper. and that work needs to be uploaded as well. Right, so prepare well. पहले वाला क्विज कम लोगों ने दिया है और मार्क्स भी अच्छे नहीं है. So prepare well for this quiz. That is all from my side for today. Anything anyone wants to add? Okay, so I'll end the meeting now. We'll meet tomorrow.